Hey everyone, welcome. We're going to get started in a few minutes. Hi everybody. Good morning. I'm just letting everybody in here and giving everyone an opportunity to come on in. Let me go ahead and lead us into the quick check-in. We'll use the chat for this one. It is Thursday already. It's crazy. It's gonna be Friday tomorrow. But anyways, it's Thursday. September 24th. Nearing the end of September here. Okay, here's the check-in question. How old were you when you got your first cell phone? Go ahead and put that into the chat. And then that way I'm gonna, double check our attendance here. How old were you? I'm gonna put my age. Oh, wow. A lot of us are like, we're preteen age or in their teens. Wow. The youngest is 7. Preteen and teen is like the more of the common one. Wow. Like with service 15. Yeah. Yeah. For me, yeah. Back in the day in my time, I already feel like a grandpa. Um, they had that old school texting ones. They would just text. You couldn't really look up stuff on the internet. And it would be the ones where you have to push a button multiple times to get a letter and so forth. Those old school ones, they're like the flip phones as well. So I didn't really need to text friends as much, I guess. I didn't really have much friends. So I had no need for a phone back in that time. And then I finally decided I needed a phone once I hit college and I was 20. And prior to that, I would just use my dad's phone, actually. I would just borrow my dad's phone and I would use that to contact people. And then my dad was all like, "You need your own phone now." So I was just like, "Oh, you're right." My dad gave me one of those that got stolen. Ah, that's funny. Awesome. Let me go ahead and repeat who I don't have here. Yeah, and then nowadays I'd be seeing like 5-year-olds having a cell phone, or I don't know if those are like the ones maybe like Rosa where it has no service and it's just for the fun of the Wi-Fi and so forth. But anyways, I don't have Kaylin, but for Kaylin with a C. But Kaylin has checked in with me, so we don't need to text him. Um, Next, I don't have Fernanda, so someone can text Fernanda, let her know. I mean, if you're here, let me know if I missed you in accident or something. Yeah, I don't have Fernanda. I don't have, is that correct? Nope, James is here. I bad, I forgot to check you off. The next one I don't have, I believe, is Grecia. Let me know if you're here, Grecia, but I don't see you. So who I don't have right now is Fernanda and Grecia. So again, if you're friends with them, if you could please give them a text or something, and I'll update the attendance once they come on in. All right, y'all. Welcome, welcome. Let's go ahead and talk about our agenda today. So we had our attendance and check-in. We're going to be doing that group activity that we didn't get to do last time. It's on Google Classroom. We're going to be put into groups. This one's going to be random groups and so forth. Analyzing a motion graph. Then we're going to come back together as a big group. I'm going to do a quick note on how to find the average rates of change given a position graph. Average rate of change in another way is saying like velocity as well, average velocity. And then we're going to do a different graphs activity, which again might be groups or not. It's going to depend on our timing, depends what we get through today. As a reminder, asynchronous number 4 is due tonight. Now I did enter grades yesterday for async number 3, but let's say that you didn't have time to do it and you just need more time to do it. Just let me know. Some of you have added me on Remind, some of you have not. Definitely make sure you have me on Remind. So my Remind is if you text 81010. So you're going to type that number and you're going to put at AP Sedano. You should add my, because like only 5 of you have added me on there. So you want to make sure that you add me that way. Text me and let me know if you need more time on something. I'm happy to take a look at it. I don't get any notifications when someone submits something late on Google Classroom. So just, it's best if you text me to let me know if you need me to look at something to regrade it or add a score to something if you turned it in late. Totally. So again, just make sure that you keep in contact. That's the key here. All right. Because I do have, I have 9 of you right now in my classroom. So I think I need about, of those who are here, 4 more perhaps to be added. Yeah. But yeah, so just a little note on any late work or anything like that. Again, if you need more time, just let me know. I'm happy to provide that. and give you full credit, especially if we're within the weeks here. So it's like best to, take care of that within the week. Let me know. I'm happy to work something out with you. Awesome. All right, everyone, let's go ahead and jump on in. So this is the group problem that you'll be doing in your groups. Yay, we got some more people adding in the AP Calculus. Woohoo. Okay, and let me go to my Google Classroom so I could show you once you hit your groups, what it looks like. And basically, once you're in your group, we don't have like the facilitator, stuff. You guys are just gonna have to organize yourself. Go ahead and decide who's gonna share the screen, who's going to type out the work there. So we're in AP Calc. And the sheet that you want to open is this one. And let's see. And it's not an assignment. So basically, it's not an assignment, but you have to do it as a group. Once you're in your groups, you're gonna put everyone's group name and you gotta share it with me. That's how I'm gonna actually see that you did it. You'll put everyone's name in the group. So basically, I think we'll have about 4 groups. So I should get about 4 submissions. You're gonna put your names and everyone's gonna work on answering these questions and so forth. Let me know if anyone has any questions on that portion, on what we're going to be doing. Again, you're not turning this in separately. You're only turning in one per group. How you turn it in is by sharing with me, and it'll pop up in my email. All right. So before you all go ahead and work in your groups, I wanted to give you all 3 minutes first to get some piece of paper, something, and or you don't need, if you don't need a piece of paper, that's okay. Just take some moments to read the questions that you're going to be asked so that you have something to prepare to share with your group once you're in there. Let's take 3 minutes to just process this. All right, cool. That was just our independent processing time. Processing, sorry, I just saw that text. Are we writing down the answers down or just processing? Totally fine if you just processed. I didn't write anything down when I looked at this. I was just processing and looking at the graph itself. But basically, the writing down happens as a group. So it's okay if you just processed right now. All right, everyone, I'm gonna go ahead and move you into your groups. Remember the directions, only submit one per group, and how you submit is by sharing the document with me. I don't think there's a way to submit on Google Classroom. So let me go ahead and create the breakout groups. And then give me 1 second, let me take a look at these. All right, I think we're set. I'm gonna go ahead and open our rooms, and right now you should get a message.
Okay. So who wants to share their screen and just kind of like show it and then maybe type it out? Because I feel like if you share your screen, it's just easier to type it out. I don't have the thing open on this computer. I have it open on my other computer, so I can't actually share my screen. But Stormy or Kaylin, do any of you guys want to do that?
I'm working. I have like my Zoom call on my iPad, but I'm working on my Chromebook.
Okay. Do you guys have the graph open though, like the page?
Yeah, I do.
Oh, okay. Kaylin, can you make a copy of that and then rename it? I don't know. I think just renaming it the graph, and then we put at the top our names because I don't think it don't necessarily matter. But if you want, you can also just put.
Copy. Okay. So we're gonna go. Okay, so Rosa. I want to spell everyone's name right. So can everyone just spell out their name for me?
YVI.
Evie.
Shania SH
SH.
ANIAH.
I.
X-axis.
That's like to me. That looks like
Yeah,
between 2 and 3.
that's like 2.5.
Yeah,
2 and 3?
6.
yeah. That's what it looks like to me.
What? Are we
The
looking
2.5 to
different
6.
graph? No, it
And then,
looks like. Oh, okay, yeah, 2.5
Edgar,
to
bro,
6.
you're
Yeah, yeah,
tripping,
yeah,
bro.
yeah, 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 yeah. No, I see. It is 2.5 to 6.
Yeah.
She was walking fastest when it was like going the steepest, right?
Yeah, so like 1 to 2.5.
She was walking the fastest when the slope is steepest. Yeah. Estimate a time when Dominique is slowing down. When it's going down.
When there's less of a slope. So like We could say on 7 to 8, when she's going to the flat part, it's kind of like curved, it's kind of
Yeah.
rounded.
Yeah.
So it's like she's going slower.
At the time interval when Dominique was walking toward. Wait, when she walks toward it, what does that mean?
Well, I'm
Oh,
right
y'all,
because I'm still writing. I'm still writing
Oh,
down
that's when it's going down.
you want
Hold
me
on.
to oh yeah.
Oh fuck. There's also a really tiny one from like 7.5 to 9. Oh yeah, up here. Here, hold up. Is it like? Should you say like 8 to 9? Ooh. Oh, there we go. It's 7.
I would say like from 8.5 to 11, because even though it's like the slope's going down, they're still going at a faster velocity.
Yeah, speeding down. Okay.
You're right. You're right.
Evie, where you at? Where you at, Evie?
I don't know. I don't know what I'm looking at, so I don't know what to say.
Walking faster. 30. You said like 8 and 11, right? James,
Yes.
you
Hello.
said from 8 to 11, right?
Uh, no, 8.5 to 11.
Oh, I'm sorry. I had to get it punctual. 5, 11. As that, as you see a rapid drop indicating she's possibly
When we put the time interval, we put the 9-11 thing, and then when she walks away from the motion detector, is the part underneath.
Wait. Stay at the time interval when Dominique was walking towards the motion detector.
That's the first part. That's the 9x11, because that's the
Oh,
time
okay.
when she was
Yep.
walking
Oh,
towards
okay.
it.
Okay. I'm tripping.
Yep.
Okay. Okay.
And then
Wait. Yeah.
well,
Okay, but for the like second question, when she walked away from the motion detector, that's when the
Lope is going up,
no,
because
that's
that's when she's going.
I thought
yeah,
it was
because
Because
she's
that's when
getting
she's
further.
going further away.
Yeah.
Because on the Y graph, you see the 1 and the 2 feet. So when she's closer to the X line, that means that she's closer to the motion
Motion
detector.
detector.
Oh, okay.
So there's two times when she was walking away from the motion detector. At the beginning, from 1 to like 2.5 ish.
Mhm.
And then she stopped, and she was standing still, and then she kept going
Yeah,
Okay.
like a bot,
I'm like, I
like a
was so
bicycle.
confused.
like a bot. Why was she standing still?
Oh man, she was selling the bag, man.
She was selling the bag.
Yeah, we don't have no
Oh,
questions.
where's some demons at, Matthew?
But you can say also from, I don't know. Yeah, from 6 to 8.
Oh my god, bro, I can't type. 6, 3, like the least progress is made because from like 1 to like from 0 to like 3 she had walked already on, and number 6 to 8 she hadn't really walked. Sort of, I don't know.
I really don't know. After A and B, I get confused. So, yeah, I don't know like how to really justify. I don't know. I don't know. I'm a little confused.
I feel so dumb right now. Like I just
Feel like that. We're gonna discuss it. By the way, y'all, can y'all share me on this document as well so I could take a look at it?
share. So, I don't know how it's like because of my school is different. So,
Perfect. Thank you. And that's okay. Y'all can come back to see as well. And then just move on. You know, that's okay.
what's the motion detector? Where is that?
Oh, that's a good question.
How am I gonna know?
So let's make the assumption that the motion detector is at the origin. So 0,0 right there.
Mm-hmm.
That's a good thing to actually ask. So let's make that assumption because she starts from 0. So I would say that the motion detector is right there at the origin.
So the question is asking when she walked away, not when she was furthest away.
Let's see, which one? Are we talking about part D?
Yeah.
At the time when Dominique was walking towards the motion, yeah, so back towards it. Like she first walks away right at the beginning, right? She's going farther away from it. But when is she walking towards it, like back towards it? Like she turns around.
But I'm saying like the second question, because under that it says when did she walk away from the motion detector? So I'm saying like, is it asking
Both.
like,
Yes, that's correct. The first one's when she walking towards, like around what seconds, and what seconds is she walking away from it? Perfect, perfect. I'm gonna bounce into other groups, y'all. Sorry for the car noise I have over here. Awesome job, y'all. Keep going. You out there doing great.
Get confused. It's just like putting like, oh, he's because it's like the detective's at 0.5 or like an estimate of that, and then the second sentence they already put it. They're walking away from it, starting at 1 until the curve starts to come back down. But I think besides that, I think we're pretty good. I think we've answered all the questions, and we don't have too many questions. But yeah, you can turn it in unless you have anything else, Taylor.
I don't know. Stormy, you think it's good?
I think it's great. Like, it's just guesses, right? So it doesn't have to be perfect.
Does not have to be perfect.
I
I don't know if y'all knew I was here. Oh, by the way, how you turn this in is you share it with me. So just share the document.
Oh, okay.
By the way, y'all, did y'all make the assumption that the motion detector was at the origin? Yes.
No.
Okay, where did you all say the motion detector?
Well, we thought that maybe it started at where the person starts.
Okay.
And then because it doesn't necessarily say it's at the origin. That was one of our questions actually. We're like, does it start at the origin or does it just start where they start? But we just based it off of where he started instead of the origin.
That's okay. Perfect. That's fine. Some groups assumed in the origin. You could have also assumed from where the person started. That's okay. Awesome. All right. So this group is good. We'll probably come together in about 2 more minutes. And let's see, who am I missing? Okay. I'll be back, y'all. Hi, everybody. How's it going?
Good.
I think we're done.
Yeah.
Was I shared on it?
Oh.
I don't think Shannon shared it yet.
My bad, my bad, my bad.
I told you.
My bad. I know you.
Shannon's selling, yo.
Shannon's selling the bag.
I really did like blink out. Okay, I shared it.
Perfect. Cool. A question I have for this group is, did you all, where did you assume the motion detector was?
Oh,
I assumed
0.
at the
What?
top.
Okay, at 0. That's perfectly all right. Perfect.
Well,
All
no,
right.
that's just me. I don't know how they like assumed it.
Yeah, I think when I looked at it, I assumed it at 0. Other groups assumed it from where the persons began walking. Either one would be fine because it doesn't specify where to start.
All right.
Okay.
All right, I'm gonna bring groups back in. Hey everyone, we're still waiting on a few of us to come back in. Let me just share my screen so we could take a look at the amazing work that all groups were doing. Check out questions. Yes, it's a good question. All right, I wonder, okay, we're getting everyone back already. Awesome, I'm hoping I have everyone back now so we could go ahead and talk about this. And it's okay if your group didn't 100%, get to finish. You'll be getting your credit, so don't worry about that because in all the rooms that I popped into, everybody was like on task. Yeah, you want to put all your names on there too, just so that I could remember who was, doing what. So yeah, I think the names are here. Yeah. All right, cool. So just looking through some of the work, I noticed that everyone pretty much was okay with identifying when Dominique was standing still. When the graph is flat was mentioned. In other groups, we have because it wasn't going up or down, which is, another way to say flat. This group identified more than one. This from 3 to 6 and also 12 to 14. Again, it looked flat for these groups right here, okay? And for this group, 2.5 to 6, so again, we have that flat portion. And then it says from 11 to infinity, it's flat because she wasn't moving. The height drops becomes consistent is another way this group says, it's flat there, locally flat in the graph. This one has, I think, 3. I don't know if the rest of them had 3. So it had from 2 to 6, yes. And also 12 to 15. And in addition, this one's new. This group had a new one, 7.5 to 9. So around 7.5 to 9, they also identified another flat portion. So the everybody's right because you all at least identified intervals in which Dominique was standing still because the graph was flat or the Y value wasn't changing. The one that's more accurate is this group. They identified the 3 different points where it's flat. It's right here. It's also right here at the maximum point, and then also down here. So there should be 3 locations just to clarify that portion for everybody. Let me know if anyone has any questions on that. All right. As I was jumping into groups, I noticed a little bit of different answers for part B about when is Dominique going the fastest. So I did notice though, steep slope was coming up a lot. So this one says 9 to 11 because the slope is the steepest. So let me go ahead and use my tool. Just gonna from 9 to 11. Wow, it's yellow. You have a slope that looks like that, and yeah, it's a steep slope. But I also had groups that thought a different options. Let's see what this group says. This one said from 0 to 2.5, which I think was the most common answer I saw for this one. They thought this slope was the steepest instead of, like the other group said, this one. So it might be a teensy bit like kind of hard to see, like between those two, which slope is the steepest, unless somebody wants to make an argument for that. Because one is going positive, one is going negative, but the steepness is what matters when we're talking about the fastest or least fastest and so forth. And if you actually wanted to figure it out, you would calculate the actual slope by using 2 points and so forth. Okay, 9 to 12. This one also said at the last part down here, like as she's going back towards the motion detector, that it's going fastest. And when there's less of a slope, that's slowing down. This one was again from, so it's about half. Half of you said at the beginning she's going the fastest, and about half of you said when she's coming back down towards the motion detector. So just taking a look at those. Like I said, for that one, it's kind of hard to determine which slope is steepest. But if it was me doing those lines, I would think it's the second one, unless someone wants to make an argument against that. So we have this slope, or there's this slope. Like visually to me, the second slope looks more steep. But yeah, up to you how you see it, because it looks longer and then she's covering the same amount of distance faster is what I'm seeing when I do those lines. So I would kind of lean more towards the 9 to 11 or 9 to 12 as going the fastest. All right, great. So let me go ahead and move down into the last one I definitely want to talk about, which is when is she slowing down? So some groups I heard using words like when it's less steep. This one says when there's less of a slope, from 6 to 7.9. So from 6 to 7.9. So this right here was when she's slowing down. All right. Oh, this is just my fresh copy. This one also says 6 to 9 because it looks like he is slowing down towards the top. So again, this group believes it's this little curvy part right here. This one says from 6 to 8. Yep. And then this group says 10.5 to 11.5 and 6 to 7.5. Okay, so the same one here, but then there's an additional one from 10.5. Where's that? 10.5 to 11.5. For that one, I'm a little bit curious if whoever was in this group about what you mean about that one. Let me go ahead and draw it on my thing. So 10.5 to 11.5, maybe around here. We think that there's a slowdown happening. Does anyone in the group kind of want to share why they thought that? And it was Sophia, P, G, Roxana, and Israel. Let me go back to this. So again, my question is, I'd like to know a little bit more info about why you all put the slope.
I guess we got the intervals wrong, but it's supposed to like curve down all the way to like almost 12. But our thought process was that it has like a curve to it instead of just like abruptly stopping. So that means that it has to be slowing down.
Oh, okay, because this is curving like this instead of like sharply going down. Let me know if I got that right as far as your interpretation. Awesome. Cool, y'all. So thank you so much for sharing. So I definitely wanted to kind of talk about the slowing down portion. So I was also wondering too, for that group that answered that, I was wondering if it's because this little bump right here, how it kind of bumps up a bit, and like that could be interpreted as a slowdown. I was wondering about that one too. And I have no idea why my color is yellow. Let me change my color. All right, so the slowdown. I mean, totally. If we're talking about like a slowdown happening, yeah, I could see a gradual, right, as well. It's not abruptly stopping there. I want to talk about the one that everyone identified, which is this portion right here, from here to here, was where we said the slowdown was happening. I did see some groups kind of struggling with describing why the slowdown was happening there, or like kind of justifying why there is a slowdown happening. And I want to kind of push us back to use slope and steepness, your definitions on what you know about that. So for example, if I were to draw a line from here to here, I know that's very steep. She's going quite fast. She stops right here. And then because this is curvy, I'm going to do smaller slopes. And each time that my slope is, for example, this slope is more steep than the second slope line I drew. It's very, very small, but you can see that the slope is getting less steep over time. And when it's getting less steep over time is when the person is slowing down. And that's what I would encourage you to use in your definitions when talking about this. Let me try to make that more clear though. Again, this slope like this, we got a second slope, and we got, it becomes vertical. I wonder if I could change the color. Very hard to see it, but the slope gets less steep each time as you go up. So this red one is more steep than the blue slope. And then this one here is completely at a zero slope, it's flat. So it gets less steep means the slowdown is happening and she's slowing down. So just bringing us back into the steepness of a slope and what information it gives us with the graph. And then that's what that group did right here as well. But some groups did struggle, so that's why I'm talking about that right now. Awesome. But otherwise, I'm so like very much pleased with all this work that we have. A common question that was asked was like, where is the motion detector? So that one was left up to you. I did tell some groups like, go ahead and make the assumption that's at the origin. Some groups made the assumption that I was right here at about 0.5 or something feet. That's okay if you made either assumption because the problem did not specify exactly where was the motion detector. So, but either assumptions that you all made, we came up with like the same answers. So it's totally all right. All right, cool. So let me know if anyone has any questions about what we just went over. Awesome group work, everyone. Let's go ahead and transition us back into our notes. What you do need is a piece of paper, pencil for this portion right now. Let me go ahead and go and find our slides. Oh my gosh, did I X my slides? It's weird. Go ahead and X this. Cool. I guess while I'm getting the slides open, you guys can go ahead and get some paper, pencil, as we transition into our notes. All right. Awesome. So now in our notes, we're going to go ahead and review how to calculate average velocity, which is the same thing like average slope, kind of like what we did in pre-calc last year. When we were doing average slopes, like it was in the last unit. It's okay if you don't remember because I'm going to go over it. How do we calculate average velocity? So if you're given a position graph, how do you get the average velocity from it? And a lot of you, have brought up the ideas of using slope and so forth. Questions that came up from asynchronous number 4. So asynchronous number 4 was the FET activity. That's the one with the moving man. You had to move him around and made some connections. And here's some questions that came up and I just took them and pasted them. I didn't fix any typos, nothing like that. It says, why does velocity go negative when the man is walking backwards? Very, very good question. The other one is, if you're going downhill, will the velocity go negative? Have of it going down? Yeah. So that, like I said, I copied and pasted it, but both of these came up where it's, why is the velocity negative? When the person was walking backwards or back towards the motion detector or back towards the starting point is the question that came up. And it's a perfectly valid question. And hopefully we could like answer this. So go ahead and do a rough sketch of this graph here in your notes. This is a problem I took from Khan Academy. What it is, it's a position graph, and it says, the question we're being asked is, what's the average speed of the ladybug? So it's a ladybug that's crawling on a leaf between these 2 seconds. Okay. First, we're going to go ahead and do average speed, and then we're going to talk about average velocity using this very same graph. This one you have multiple choice, but we're going to talk about velocity after. Okay, so let's see. So a ladybug crawls vertically in a leaf. Its motion is shown in the graph of a vertical position, y versus time t in seconds. Okay, so how do we calculate average velocity? Average velocity is going to give us average speed in a position graph, because speed is defined as distance over time. Maybe y'all can write that down. Speed equals distance over time. It takes me forever to write this. Distance over time. I'll just put t. Speed is distance over time. Basically, that is the same thing as doing change in y in this graph over change in x. So basically what we're doing is finding the slope of the 2 points. That's going to give us speed. Definitely write down this thing because you want to know what's the difference between speed and, velocity. So between 4 and 7 seconds, the question is saying, so here's 4. I'm going to go up to my graph and I'm going to put a dot right there, 4. And then 7 it is right here. So we're going to go up. Maybe some of you can already tell the answer at this point on what is the average speed or what's the slope between these 2 points. But if you don't know, I'm going to go ahead and show you a walkthrough just so that you have that tool. Some of you can already see that though. How we find the slope between 2 points is you go ahead and have your coordinates. So this is going to be 4, 2. And this one's going to be 7, 2. So you have your 2 points. And what we're going to do is we're going to do change in y over change in x. So this is going to be x1, y1, x2, and then y2. So we're going to go ahead and find the slope. And as a reminder, that's y2 minus y1 all over x2 minus x1. Oof, this takes a lot of work to type this or to draw this on here. Okay, so y2 is 2, y1 is also 2, so 2 minus 2 all over x2 is 7 minus 4. 2 minus 2 is 0. 7 minus 4 is 3. If you use a calculator or if you already know the answer, you get that the slope is 0. And because y represents distance in meters, that's going to be meters per, and the time was in seconds. So 0 meters per second would be the answer to this here question. So that's the speed, 0. Also, you can visually tell that it's 0 because the line is flat. That means, as you all saw in the last problem, when the line was flat there, you're not moving, right? Because the y value is not changing. So you could already see that, well, then if we're not moving, we don't have any speed. So the speed would be 0. All right, so now let's talk about velocity. Something that you should know about speed, distance over time, is that it's always positive. Velocity, though, is defined as, velocity has now a different definition. That's defined as displacement over time. And displacement can be negative. That's the difference, y'all. So speed is always positive. Velocity, on the other hand, can be negative or positive. But they're very, very related. So this is displacement. I hope you all can read that. Displacement over time, which will also be this. It will also be change in y over change in x. The only difference between speed and velocity is basically speed is the absolute value of velocity. You just take whatever velocity you have, make it positive, that's your speed. So speed is the absolute value of velocity. I wonder if I could type that out. Let's see. Right here. Velocity, it's always positive. And I'll just give you a heads up though, here in calculus, so this is the note you want to definitely write down. Here in calculus, we're mostly going to be dealing with velocity. We're not really going to be talking about speed. The reason why we mostly prefer to talk about velocity is because velocity also tells us direction. It tells us whether it's going forward, whether it's going backwards, and how you could tell it's whether velocity is positive or negative. It's going to give you that information. So that's why we prefer in calculus and in physics to use velocity. Speed gives us less information. Us in the real world, though, of course, like if you're talking about traveling car, we always just talk about it in speed. But we also mention velocity. So it's something that we mention, but not naturally do we think of it as being negative. All right. So let's go ahead and do another calculation with the same problem, but now we're going to do velocity. I hope y'all have this down. I wonder if I can clear my board. If someone needs more time, if you could unmute or put it in the chat. Need more time on this slide. All right, I'm gonna go ahead and clear my drawings so we could, do the next problem or the next one, clear all. Okay, so for the next one, for the sake of not being confusing, what I'm gonna do is I'm going to take this out. There we go. Now I'm just using the same graph because I don't want to talk about speed now. So now let's say I want to find the velocity from t equals 0 seconds equals 0 from t equals 4. Let's say I want to find the velocity. So remember, velocity in a position graph is mostly going to be change in y over the change in x. Again, that's displacement over time. And again, displacement is like distance, except it can be negative. So again, we already wrote down displacement over time, so we don't have to rewrite that. So let's go ahead and do the same strategy. So we need our two coordinate points. So this one is going to be 0, 6. And this one's going to be 4, 2. And again, you could label your points. So I don't know which one. This one could be x1, y1. This could be x2, y2. So let's find our slope. So y2 minus y1, that's 2 minus 6. All over x2 minus x1, which is 4 minus 0. I see something in the chat. Let me pause. Oh, okay. In the chat, we have an answer. Someone said, is it -1 meters per second? Rosa put -1. Okay, look at that. Everyone's saying -1. All right, so I'm gonna just go ahead and finish this up for those who need the support. So we get -4 up here because 2 minus 6 is -4. And then we get +4. So yeah, we get -1 meters per second. So notice let me ask you this in the chat, everybody. So, okay, we got that the velocity is negative meters per second. Let me ask you all this. In the first 4 seconds, is the person moving forward or backward? In the chat. Is the person moving forward or backward given that the velocity there is negative? How is this person moving? Yes. Great. So notice how the velocity will give you information about whether or not person is moving forward or backwards. Yes, it's moving. The person is moving backwards because the velocity is negative. See how that gives us direction? If I said, hey, what's the speed, everyone? The speed, how fast this person is walking, is 1 meters per second. Remember, speed is the absolute value of velocity. Awesome. So that's basically one of the key things here. You know, when is the person moving forward, backwards, so forth, and what's the difference between speed? Awesome, y'all. So let's see. We have about 2 minutes. I don't know if anyone has any more questions for me or anything, but this is how you would calculate velocity given the speed graph. Given the position graph, and just knowing the difference between velocity and speed is super important in this investigation. And it's also going to lead you into today's asynchronous number 4, I believe it is, where it's Khan Academy. You're going to take notes. You're going to look a little bit more detail about how to analyze position graphs and so forth, just to get additional practice on that. Let me know if anyone has any questions. But if not, y'all, I hope you all have a great day. We're at the end of our class. Yeah, woohoo, it's Thursday, everyone. Tomorrow's Friday. Bye, everybody.
Bye.
Bye.
Have a great day, y'all. Let me know if anyone has any questions. Oh, cool, you can do that? Bye. Who's doing that? That's cute, though. Bye. Oh, it's James. Bye, James.
I have a question, Mrs. Dani.
Yes, what's up?
So are you gonna post another asynchronous work that's due Sunday, right?
Yeah, that's correct.
And then the one the Khan Academy is due tonight, right?
That's correct. And again, like if you need any more time, just let me know. I'm happy to give, you know, if it seems too much, any extensions.
Okay. Thank you.
You're welcome. Bye,
I
James.
see you Monday.
See ya.